Hey there. All right. Today we are going to talk about radicals. We're going to continue on with that, and we're going to look specifically at radicals that cannot be divided. And we're going to learn what we can do with that. And it's a technique or a concept called rationalizing. So if something is rational, then it makes sense. And mathematically, if it's a rational number, it means it has an end. So then what's the opposite of rational? Well, irrational. And what's everybody's favorite irrational number? Pi, right? So an irrational number is a number that goes on and on and on and has no end. So to make something rational is really useful. Lots of irrational numbers are square roots, like the square root of 2, or the square root of 5, or the square root of 6, or the square root of something that's not a perfect square. So our goal today is to do something we called rationalize a radical. So let me show you what this looks like. So let's say we've got the square root of 5 divided by the square root of 2. What we talked about yesterday, or in our last lesson, was that when we're dealing with radicals, we divide coefficient by coefficient, and radicand by radicand. Well, in this case, there's nothing to do. 5 doesn't evenly divide by 2. So we're going to do something called rationalize it. It's bad etiquette. It's rude, if you will, mathematically, to leave a radical in the denominator. So our goal is to have no radicals in the denominator. Okay, that's our goal. No radicals in the denominator. So there's a really simple yet brilliant way to get that radical out of the denominator. So everybody knows, as a side note, that if you multiply anything times 1, you get the same number, right? Like 5 times 1 is 5. And 10 times 1 is 10. Well, aren't there other ways that we can write a 1? Can't I write 1 as like 2 over 2? So if that's true, then I can multiply 10 times 2 over 2, and I should still get 10. And if I do that, 10 times 2 is 20. And 1 times 2 is 2, and 20 divided by 2 is 10. So if we take that idea and we apply that to our radicals, we can do something very similar. We can take our bottom radical, in this case, the square root of 2, and we're going to use that to create a 1 that we can multiply by. So what if I multiply this fraction by the square root of 2 over the square root of 2? Because isn't anything divided by itself 1? Isn't this essentially the same as 1? I'm just multiplying by 1, and everybody knows that if you multiply something by 1, you get the same thing. So if I do that, what's going to happen here? I'm going to get the square root of 5 times the square root of 2, which is the square root of 10. And in the denominator, the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4. And what's the square root of 4? It's 2. So then my answer, my rationalized version, is the square root of 10 over 2. So let me say that one more time. The goal was to rationalize this function to get rid of the radical in the bottom. We want our denominator to be free of radicals. To do that, I took the root in the denominator, and I multiplied by it over itself because that's the same as multiplying by 1. Then I simply multiplied the numerators together, so the square root of 5 times the square root of 2 is the square root of 10. And in the bottom, I had root 2 times root 2, which happens to be 2. Therefore, the square root of 10 over 2 is the exact same thing as the square root of 5 over the square root of 2. This is simply a rationalized version of it. So if you're asked to rationalize a function, that's what you do. Let's try another one. What if we have 4 over the square root of 3? Now this time I only have a radical on the bottom, which is totally fine, but it's poor form in math to have a radical on the bottom. It's not wrong, there's just a much better way of doing it. So if I'm going to rationalize this, I'm going to look immediately at my denominator and find the radical. I'm going to use that radical to create a fraction that is equivalent to 1. So itself over itself, root 3 over root 3. If I multiply this, I'm going to get 4 times the square root of 3, which is 4 root 3. Not much to it. In the denominator, root 3 times root 3 is 3, because isn't it really root 9, and what's the square root of 9? 3. It will always create a perfect square that you're taking the radical of. So the answer, you'll see a pattern. Root 3 times root 3 is 3. Root 4 times root 4 is 4. Root 5 times root 5 is 5. All right, let's try one. I'll give you one to try. After I write it down, you're going to hit pause, work it out yourself, come back for the answer. All right, how about the square root of 6 over the square root of 5? Okay, try to rationalize this. Hit pause. I'll wait. Okay, ready? So we've got a radical in the denominator. We're going to multiply by that over itself, which is a fraction that equals 1. This will give me in the top the square root of 30, and in the bottom, this will give me 5. So root 30 over 5. How'd we do? Do we do okay? Okay, let's look at how this can take on different forms. So let's look at this one. Let's say we have the square root of 5 divided by the square root of 8. So if we're going to rationalize this, we're going to take the bottom radical and we're going to turn it into a fraction equivalent to 1. So root 8 over root 8. Multiply this through, and we're going to get the square root of 5 times the square root of 8 is the square root of 40. And in the denominator, we're going to have 8. Okay, so this is good. This makes sense. But here's my question. Can we simplify this root 40 down? So if I take 40 and I make a factor tree, I'm going to get 4 and 10, 2 and 5, 2 and 2. My 2's appear twice, so I can rewrite 40 as 2 root 10, right? Because 2 times 5 is 10. And now that's over 8. This can be simplified. I can simplify that 2/8 to 1/4. So this is really root 10 over 4 as your final answer. So once you're done rationalizing, you still need to be careful to check to see if there's any simplifying that can happen. So try this one. How about the square root of 2 divided by the square root of 6? See if you can rationalize that and make sure to simplify. Hit pause. I'll wait. Okay, you ready? So we're going to rationalize with root 6 over root 6. And that's going to give us the square root of 12 over 6. Now 12 looks like something I can break down. And sure enough, 12 would break down to a 4 and a 3 and 2 and 2. So I can take out the 2. I'm left with root 3 over 6. The 2 and the 6 simplifies, and we end up with root 3 over 3. And that would be our final answer. Now, the last one I want to talk about for right now is what happens if you have a coefficient already. So let's take a look at this. Let's say we have the square root of 3 over 2 root 5. So this one is different because we have a coefficient outside of the radical. It's not going to change anything. We're still just multiplying. So what we're specifically going to do is only use the root 5. So I'm going to multiply by root 5 over root 5. If you choose to put that 2 in there, like if you did this, you would have to do it in the top and the bottom because you're trying to make a fraction equivalent to 1. All you're doing is making bigger numbers and being less efficient. So the 2's are not the most effective way to do this. So we're only going to use the radical. When you multiply this through, you're going to get the square root of 15 in the numerator. And in the denominator, you've got 2 times 5, right? The square root of 5 times the square root of 5 is 5. And this 2 is still here. So times 2. So that means we've got root 15 over 10. Does root 15 break down any further? Can we simplify that? No, it only breaks down to 5 and 3. Okay, let's try one like that for you guys. So rationalize for me root 3 over 2 root 6. I'll wait, hit pause. Okay, hopefully you chose to multiply by the square root of 6. If you did that, you got the square root of 18. And in the denominator, you're going to have 2, that 2 is right here, times 6. So that's going to be root 18 divided by 12. Now, does the square root of 18 break down? It does. If we broke that down, we would get a 9 and a 2, and we know that that 9 can break down to 3 and 3. So that's going to give us 3 root 2 over 12. The 3 and the 12 can simplify to root 2 over 4. Good job. That's it. I'll put up some practice problems and we'll give this a go.